All right, so let's talk through the second part of skill 12. This is about theoretical air capacity of an engine. This is related to displacement, as so many things are. The idea here is, you're trying to do a calculation for the maximum volume of air that could pass through an engine in 1 minute. So this depends on what the RPMs are, right? If the engine is running faster and doing more revolutions, then more air is going to run through it. So you need to have a particular RPM. Essentially, it's not really anything more complicated than just taking how many revolutions per minute, how many RPMs, and multiplying by the displacement. The one thing to keep in mind is, as I understand it, right, in an engine, for every sort of revolution, half of the cylinders are drawing in air and the other half are exhausting the leftovers after the combustion. So it's not totally just the RPMs times the displacement. You essentially have half of the cylinders sort of working for each rotation. So in some sense, right, our TAC, our TAC, the theoretical air capacity, is, the RPMs times the displacement divided by 2. Right, in theory, it's however many sort of revolutions we're doing in a minute times the displacement, which is just our sort of volume, and then divided in half because half the cylinders are sort of intaking and the other half are exhausting. Now, there is a unit conversion that happens because, of course, there is. Normally, our displacement is measured in cubic inches. So CID, right, is our normal displacement, cubic inches of displacement. That sort of tends to be what we use, right, because we're measuring the parts of the engine in terms of inches, or liters, right, but we're just doing this from an American units perspective. If you do cubic inches of displacement times the RPMs, honestly, you're just going to get a really big number. And so to keep the numbers down a little bit, our theoretical air capacity, we're going to measure in cubic feet per minute. And so if you have the displacement in cubic feet, you can just do the RPMs times the displacement in cubic feet and divide by 2, and you're good to go. We, however, will almost never have that. So instead, right, we're often going to have the displacement in cubic inches. So we need to do a unit conversion. And so the version of the formula with that conversion is, rather than dividing by 2, you're dividing by 3,456. That probably seems like a number that came out of nowhere, and it's just sort of somebody picking numbers out of thin air. But in fact, 3,456 is 2 times 12 cubed, right? So inches cubed to feet cubed, right? 12 inches per foot, so 12 times 12 times 12, 12 cubed, times the 2 that's already there, right? Because we're sort of cutting our value in half because of the intake-outtake thing. We end up with this 3,456. So what we're going to use almost always is this RPMs times the displacement in cubic inches divided by 3,456. If we look at the examples here in the book, just sort of quickly, this is in theory a pretty quick calculation if we sort of have everything laid out, right? So if what is the theoretical air capacity? Right, if it's a 402 cubic inches of displacement engine, right, CID is our displacement, 402, operating at 3,200 RPMs, right? So spinning 3,200, the engine size is 402 cubic inches. So all we're going to do is sort of sub this into the formula. We need to use the version in cubic inches, right? So that means we're dividing by 3,456 rather than just dividing by 2. But if we sub these numbers in, right, 3,200 for the RPMs, 402 for the engine, divide by 3,456. This is a pretty quick calculation. We just sort of calculator style do it up. We're going to end up around 372.2. So that's cubic feet per minute, right? So we've converted from cubic inches to cubic feet. We've sort of done this calculation, and that's our unit. So that's our theoretical air capacity. So that's under sort of perfect conditions, with everything running sort of as smoothly as possible, all the parts, right, at sort of peak performance, everything, perfectly intaking all the possible sort of, air and fuel it can, and going from there every single cycle. Now, in reality, things are probably not perfect, hopefully, right? If you guys have done your jobs well and the engine is a fine-tuned machine, we're going to get close to that. But in reality, we have an actual air capacity. So this is if we sort of use a tool called a dynamometer sensor. We can sort of actually measure how much air is sort of going through the engine. And then we can do a comparison to find what we call the volumetric efficiencies. So this is essentially just an engine efficiency thing, right? So what we're doing is we're just comparing an actual measurement versus what the theoretical possibility is. And so if we just do a quick ratio and sort of just multiply by 100%, we're going to get, right? So the actual divided by the theoretical times 100 is going to get this volumetric efficiency, right? So that tells us sort of how efficient our engine is versus what's theoretically possible. So if we recycle the engine from the example we just did, right? So that had a theoretical capacity of 402. So if we measure this and we find the actual capacity was 332.4 cubic feet per minute, the efficiency is going to be a matter of just subbing it in here, right? So the actual was 332 over the theoretical, which was 372, right, which was the answer that we found up here. So if we take that, divide, times it by 100, that's going to give us a percentage of 89%. So, not bad. A B+, a solid B+, almost an A- for this engine performance. And that's the basic idea. So the efficiency is just a quick calculation based on our sort of percentages here. Our air capacity, the theoretical air capacity is coming from this. So displacement times the RPMs and then divided by either 2 or this 3,456. I want to take us over, as always, we can sort of take these formulas, rearrange them just a little bit. We can sort of take it from a little bit of a different perspective. So if we jump over to some of these homework questions, you guys are doing the evens in this section, so I'll do one of the odds here. 9 and 11 is very similar to the one in the book. 13 is sort of asking things in a little bit of a different way, so that's what I want to focus on. So what is the displacement in cubic inches of an engine running at 2,600 RPM with a theoretical air capacity of 362 cubic feet per minute? So as always with these formulas, we can kind of rearrange them a little bit and sort of give it different information. We can sort of use it to solve for other pieces. So rather than sort of starting with the displacement and finding the air capacity, if we sort of know the air capacity and we know the RPMs, we can sort of reverse engineer what the size of the engine is. We can reverse engineer the displacement. So our setups here, right? So find the displacement in cubic inches. So we're using the 3,456 version. We're kind of always going to be using that, right? We said we're probably not going to get displacement in cubic feet very often. So the RPMs are 2,600. The theoretical air capacity is 362. So all I'm going to do is sort of sub those values in, right? So my theoretical is over here, right? My TAC, my theoretical air capacity, my RPMs, 2,600 are up here. And I'm trying to solve for the displacement, right? So that's kind of my missing piece. Everything is over 3,456. What we'll do is we can essentially sort of take the 2,600 and the 3,456 out in front, right? We can just do a quick division with those two, just get one value there times the displacement. That should equal 362. If we do a quick calculation, we'll see that's going to come out to about 0.75. These are rounded, of course, but that's roughly where we end up. And so all we need to do there is just a quick divide by 0.75 to the other side. 362 divided by 0.75, that's going to get me a bigger number, right? Because I'm dividing by a decimal, something less than 1. And it looks that my engine size, my displacement would be 482.7 cubic inches. So as always, we can sort of take these formulas, we can rearrange them a little bit to sort of get some new information and go from there. So that's the idea. The evens are the homework for this section. Everything should be up on Canvas. enjoy. Have fun.